Hi there, welcome to this physics tutorial on electric force. Today we're going to solve the problem shown. It says, what is the distance between two oppositely charged particles if the attractive electric force between them is 2.5 times 10 to the ninth newtons? And tells us here that the particles have charges of -3 coulombs and 4 coulombs, respectively. So first of all, when it says electric force, I want to make sure I use the electric force equation. And that looks like this. F equals K times the absolute value of Q1 and the absolute value of Q2, those are my charges, divided by the distance squared, and that's the distance between them. Now our K constant is equal to 8.99 times 10 to the ninth Newton meters squared per coulomb squared. And then my Q1 will be my first charge, and remember the absolute value signs here tell you that we must make it positive. Q2 will be the charge of my second particle, and R is the distance between them. And like I said, F represents the force. Now, if my particles are oppositely charged, they will have an attractive force. So that makes sense. Attractive force, oppositely charged. If they had had the same charge, either both negative or both positive, it would have been a repulsive force. But the equation remains the same. So in this equation, we need to solve for R, the distance between them. So in order to do that, I first can rearrange this equation. And this becomes R squared equals K times Q1 times Q2 over the force. Now let me plug in my numbers, but remember, I'll have to take the square root at the end because this is R squared. So when I plug this in, I have 8.99 times 10 to the ninth newtons meters squared per coulomb squared. The positive charge of the first one is 3 coulombs, and then the absolute value, that one's already positive, of the second charge is 4 coulombs. And finally, the force that they give me is 2.5 times 10 to the ninth newtons. When I solve this out, and remember, don't forget to take the square root, I end up getting an answer of 6.57 meters. So that there is the distance between these two charged particles. So see if you can apply this equation to any other problem that asks about electric force or anything to do with electric force. Good luck!